Alright, so we're going to start computing this integral right here, which is the integral of 1 over x squared times the square root of x squared plus 4 dx. One way to start this, we could do it by trig substitution. So we can simplify this a little bit and we can claim that this is also equal to the integral of d over x of dx of x squared to the square root of x squared plus 2 squared. And the only reason I did that is because we can replace this with a relationship that triangles have, which this would be a right triangle like this. But since we can claim that this x squared, because of a squared plus b squared is equal to c squared, we can claim that this is c, so then that means x squared plus 2 squared is equal to c squared, which will give us that. So this is our hypotenuse, because c is usually associated with the hypotenuse, which will give us x squared plus 2 squared right there. And then that means that one of our legs has to be x squared, or x. One of our legs has to be x and the other leg has to be 2. So we could also claim that this is the tangent. So tangent of theta, which is this our theta. So tangent of theta is going to be x over 2. And then we could solve for x, which will give us x is equal to 2 times tangent of theta. And then from there, we can take the derivative to solve for this right here. We can take the derivative of that. Dx is equal to 2 secant squared of theta, and now d of theta. So once we do that, we can plug everything back in over here, which will give us the integral of 2 secant squared of theta d theta divided by x squared, which we can replace that and we square this right here. So that's going to be 4 tangent squared of theta times the square root of 4 tangent squared of theta plus 4. And we can, now everything is in terms of theta. So one more thing we can claim over here, we can factor out that 4 out of this, and we can simplify it further to where it equals to the integral of 2 secant squared of theta over 4 times tangent squared of theta times the square root of 4 times tangent squared of theta plus 1, and then d of theta. So then after that, we can solve this even further, and we will get the integral of 2 secant squared of theta over 4 tangent squared of theta times 2, because we took out the square root. So that's the square root of 4 times square root of tangent squared plus 1, which will also give us, this is also secant squared by a Pythagorean identity, so we can claim that this is secant of theta. So once we do that, we can see that these two will cancel out, so we're going to be left with 1 of the secants. So then that's going to be, actually we could take this out too, so we could further simplify this over here. So we can further simplify it to the integral of 2 secant squared of theta over 8 tangent squared of theta times secant of theta. Take out the constant, d of theta, take out the constant, which will give us 2 over 8 integral secant squared of theta over tangent squared of theta times secant squared of theta, secant of theta. This can simplify, which will give us 2/8 integral of secant of theta over tangent squared of theta. And then another thing we can notice is that we can simplify this even further, which would be 1/4 integral of secant, which is 1 over cosine. So 1 over cosine of theta times, this is going to be sine squared, inverse, because this is going to be upside down, so it's going to be cosine of theta squared over sine squared of theta. One of the cosines cancels, and then just d of theta. So then one of the cosines cancels, so it's going to be 1/4 integral of cosine of theta over sine squared of theta, which can also lead on to u substitution. We could simplify this even more. So it's going to be 1/4 integral of cosine of theta times sine of theta to the -2 d of theta. And we could do u substitution by claiming that sine is equal to u. So then u is equal to sine of theta, du is equal to cosine of theta d theta. So then we can replace, so d theta is equal to du over cosine of theta, which is going to equal 1/4 times the integral cosine of theta times u to the -2, and then it's going to be du cosine of theta. Cosines cancel, so we're left with 1/4 integral of u to the -2 du. And then when we integrate, this is going to be +1. This is going to be 1/4 times u to -1. So minus, and then that's going to equal plus c. So then when we do that, you can claim that it's going to be 1/4 u negative plus c. And then after that, we substitute our u back in. Wow, I'm running out of space. We substitute our u back in, which will give us -1/4 times u is sine of theta plus c. And then we could replace sine of theta with this triangle over here to x over this. So our final answer will be 1/4 times the square root. Pause that. Okay. So it's going to be 4 times x over the square root of x squared plus 4. So this is going to be a plus c, and this is going to be inverse, so we could just flip it to where it becomes the square root of, and this is negative because that's negative x squared plus 4 over 4x plus c, and this is your answer right here.